Um, okay, good morning, students. Now here I just quickly revise this part of the CPU, and again, how does it work actually? Because in the exam paper, you will get the questions from this part. Now, initially, you should know what are the parts inside the CPU. So mainly, there are 4 components inside the CPU. As you can see this diagram, we have registers inside the CPU, and we have the control unit or CU, and we have the ALU, arithmetic and logic unit. In addition to that, we have a memory called as a cache memory. Remember, there are 3 caches, L1, L2, L3. Inside the CPU, we have only the L1 or primary cache memory. Other two are L2 and L3 are outside the CPU. They are not inside the CPU. So then these are the 4 components that are available inside the CPU or processor. What are the 4 components? Registers, cache memory, ALU, and control unit. So those are the 4 parts. And cache memory, there are 3 caches, L1, L2, L3. Or sometimes we call as a primary, secondary, tertiary. Out of those 3 caches, only the level 1 cache or the primary cache inside the CPU. Other 2 are outside the CPU, L2, L3, or secondary and the tertiary cache outside the CPU. Then when you take these 4 components, remember ALU is the one which perform all the arithmetic and logical operations. Arithmetic means addition, subtraction, multiplication. Logical means and or not. And the control unit is the one which will control and coordinates all the operations of the machines. That is why there are lines or signals will be sent from the control units to all the other units. In addition to that, later I will explain to you. Control unit will do another task which we call as the decoding the instructions. Remember, decoding the instructions will be done by control unit. So then the other part is the registers. Remember, registers are the fastest memory in the computer, and again the smallest memory in the computer, as well as the expensive memory in the computer. Very expensive memory is the registers. So then just keep in mind, registers are the fastest memory, registers are the smallest memory, and registers are the expensive memory. And then the cache memory, why do we need the cache memory? Remember, the purpose of the cache memory is that we can keep the data in the registers actually. But the problem is registers are very small. Therefore, you can't keep all the data in the registers. So when the registers are full, we utilize the cache memory. And cache memories also are not that much large. They are also very small. Therefore, you can't keep all data in the cache memory. So then the data that are going to be used again and again, or data that are going to be used frequently, will be stored in the cache memory, because cache is also not large memory. So then you have to decide what data should go to the cache. The data that are going to be used again and again, or data that are going to repeatedly used, or data that are going to be used frequently, will be stored in the cache memory. So those are the components inside the CPU. And then remember this, we have 3 bus systems. Bus system means set of wires that are connecting the CPU and the other parts of the machines. So in that case, we can transfer 3 kind of data. One is the data, real data that you want to send. Other one is address. Other one is the control signals. So then we can use these bus systems to transfer the data, or to transfer the address, or to transfer the control signals. In addition to that, remember, in the exams you should know what are the registers available inside the CPU. Now here I am just giving the details about registers that are available inside the CPU. So these are the registers we have inside the CPU. Remember, program counter is a one register, memory address register, memory data registers, instructions registers, accumulators, and general purpose registers and flags. Like we have these registers inside the CPU. So these are the very fast memory. And this register, remember, normally the amount of data that can be stored in the register will depends on the word size. I'll explain the word size later. Now we know that computers word size, initially word size was 8 bits and then it changed to 16 bits and then changed to 32 bits. Now the word size is 64 bits. So then remember, this register currently can store 64 bits at a time. So that is a word size in the modern computers. It is 64 bits. That means the CPU register can store 64 bits at a time and the CPU can process 64 bits at a time. So then out of these registers, remember, one of the important thing is a program counter, PC. Most of the time you can see the past papers, there were questions regarding this register. That is program counter. Program counter is a register. What does it contain? Remember, this register contains, or this register store the address of the memory location where the next instruction is available. You know that when the programs are going to be executed, basically program means collection of instructions. Then these instructions should be stored in the memory. Then CPU, what it does, it takes each instructions one by one and execute. So that process we call as a machine cycle. So this machine cycle is the one which takes each instructions one by one and executes. So then remember, what is a program counter? Program counter is one of the register which contains the address of the memory location where the next instruction is available. So that is what we call program counter. So just keep in mind, this will be recording the memory location where the next instruction which is going to be executed will be stored. And whenever machine cycle does the fetch operation, fetch means print the instructions from memory to CPU registers. Now once it is fetched, remember this program counter will be automatically incremented by 1 so that we want to find out the next instruction. Next instruction is available in the next memory location. Therefore, this program counter will be automatically incremented once you fetch the instructions. Then the next register is called the memory address registers. Now, remember, when you are going to get the data from the memory, so the CPU needs to get the program counter or register which contains memory location, and that address should be placed in this register called as memory address register. That is the place we keep the memory address. So once you place this memory address in the memory address register, what happened, that will directly communicate with the memory through the bus systems and then get the required instructions or the data from the memory. So then this memory address register is a register which contains the memory location. So then through the address bus, this will be placed in the address bus and then go to the required memory location and get the required instructions from the memory. And once you get the instructions, remember that will be stored in these registers. So that is a place where we store the whatever the data or the instructions that we fetched from the memory. Once you get the memory, whatever the data or the instructions from the memory, that will be placed in the memory data registers. And after you get the instructions to the memory registers for the execution, we need to place that instruction in a special register we call as instructions registers. Whatever the instructions we bring from the memory will be stored in this register called as instructions registers. So that is the registers we will utilize here. And once you bring the instructions to the instructions register, remember, as I told you previously, the control unit get that instructions and decode it. Basically, decode means the instructions separated into two parts where you can get the operation codes and operands. So for that, we will use the instruction register and then get the instruction, and the CU control unit will decode it to find out what is operations and what is the operands that are used to make the operations. So once you decode it, that will be sent to the ALU. ALU do the calculation, addition, subtraction, will do the calculation. And once it is done, the calculations, remember, that will be saved in a special register. In intermediate values that are processed by the ALU will be stored in a special register called as an accumulator. It's a register where you can temporarily or intermediate values that are calculated by the ALU will be placed in this register called as accumulator. All the mathematical and calculation data will be stored here. In addition to that, we have general purpose registers inside the CPU that may be used for some, again, calculation data will be stored. In addition to that, we have status registers, so we call as the flags, to notify some errors, some issues that will be occurred when you are working in the computer programs will be notified using this registers called as flags or status registers. So those are the information you should know about regarding the registers. And then, as I told you, we have three bus systems: address bus, data bus, control bus. So address bus, as I told you, when you get the address from the program counter and you keep this address on the memory address registers, and then the CPU will place this in the memory address registers, and then that will go to the required memory location and then access to the memory location through the address bus. So address bus is the one where you can keep the address of the memory location when you want to determine or when you want to retrieve some data or instructions from the memory. And again, remember, this bus system means set of wires or set of lines. Again, that lines or size of the wire will depends on the word size. Currently, the computer word size 64 bits. That means here there are 64 lines. That means you can send an address with 64 bits. And the next one is the data bus. Data bus is the one, now once you keep the address, once you go to the memory, now you get the data. Once you get the data, this data is coming through another bus system, which is we call as a data bus. So that one actually you must be able to send the data from CPU to memory, and again you should be able to get the data from memory to CPU. So that is done by a set of lines or bus systems that is we call as a data bus, where you can store whatever the required data between CPU and memory or IO devices. That transfers can be occurred. In addition to that, we want to send some control signals. Basically, control unit is the one which will control and coordinates. In that case, to send the control signals, we can use the control bus systems. Then we know that the CPU executes a cycle. This cycle we call as a fetch, decode, executes. So the CPU is running this cycle continuously, fetch and decode and execute, and sometimes we save the data and then run it in a cycle. That means it will continuously running. Fetch the instructions, decode the instruction, execute the instructions, and sometimes save the instructions. Again, fetch the next instruction, decode it and execute. Again, fetch the next instruction, decode and execute. This will be running in a cycle continuously. But remember, this cycle can be broken by a signal we discuss in the operand systems. The cycle can be broken by a signal. That signal we call as interrupts. Interrupts. That is a signal which can break the machine cycle. Now we will see what are the steps in the machine cycle. Now the first step in this machine cycle is a fetch. Now what is mean by fetch? Fetch means bring the instructions from the memory and for the execution. Now, as I told you, to fetch the instructions, we should know the memory location where the instructions are available. So in this case, what do you do? We go to the program counter. We know this program count is a register which contains the address of the memory location. So therefore, we need to get the address of the memory location which is going to be executed next from the program counter. So then what do you do? We get the memory location from the program counter and we place this in a register called as a memory address registers. So that will place in the register called as memory address registers, and through the address bus, you access to the memory and go to the given locations. And once you go to the given location, you can get the required instructions. So then get the instructions. Once you get the instructions, we need to create that instructions or data on the data bus. So then through the data bus, you can get the data. Once you get the data, that data will be stored in another register called as a memory data register. Memory data registers. And then copy that data to the instructions register. Copy that data to instructions register for the execution or for the decoding done by the CU. And then what you have to do is the program counter address value should be incremented by 1 to get the next instructions. So that is we call as a fetch. That's the first part of the machine cycle. And the second part is the decoding. So decoding is the one which is done by the control unit. So what it does actually, now we have received the instructions and the instructions is saved in the register called as the instruction register. And you get the instruction and then we decode it. Normally we decode it to find out the opcode which tells you what is operation to be done. Maybe it is addition, subtraction, multiplication, divisions. Like we want to find out what is operation. Once you decoded it, you can find out what is operations. And then you have to find out for what data this will be done. So that is equal as operands. The operands are the one, maybe the numbers or the values that are going to be used for the operations, like as an example, addition. Now to do the addition, there should be some numbers. Then these numbers are we call as what? Operands. Or sometimes this will be a memory locations where you can have the data or the numbers. So then to get the opcode and operands, we use this decoding that is done by the control unit. So then once the decoding is done, we know that what are the operations that must be done and for what values we do the operations. Then we pass these values to the what we call third one is execution. So fetch, decode, execute. In the execute, what you do, we get the data from the control unit, basically the data that we received, operation code and the operands. Then we pass this data to the ALU. So ALU is the one which will do the operations. So then based on the given operands and the operations, the operands, what it does the operation. Maybe it is addition or subtraction or multiplication, division or some kind of logical operators. So we'll take that inputs and the ALU will do the performance. Maybe if it is addition, it does the addition. And once it is done, remember the results. Let's say if it is addition of two numbers, it does the addition or subtraction. The results that are coming from this will be saved in a special register called as accumulator or general purpose registers. So that is a place will be stored. If there's an error when it is doing the mathematical operations, those are reported by through the flags or the status registers. So those are the mainly the three parts. Summation, these values will be saved in the storage. So this is the next step. Once you done the processing, remember the data that you received, the partial results we received will be stored in the accumulator. Always keep in mind it's a register. Once the ALU does the performing or calculations, the results will be stored in this register called as ACC or accumulator, or sometimes called as general purpose registers. And through that, we can send the data to the memory data register. and then this data will be sent to the given location based on the memory address here, and we can save this data in the given memory location. So these are the steps in the cycle: fetch, decode, execute. Sometimes we save and then go to the next instruction, fetch, decode, execute. So that is running in this cycle. So you must have a good idea about this machine cycle. And the next important thing is the word size. Now, this is what I told you previously. Modern computer word size 64 bits. Previously, it was 32 bits, and then it was 16 bits and the 8 bits like that. So, time to time, this word size was increased. Currently, the modern computer word size is 64 bits. That has a different meanings. Remember, the 64 bits has a different meaning. When you take the CPU register, currently the modern CPU register can store 64 bits, and the CPU can process 64 bits at a time. And the other thing is this word size is related to the bus system. We know this bus system means set of wires that are connecting the CPU and the memory, and then these are connected by set of lines of wires. So when it comes to 64 bits, there will be 64 lines where you can transfer the 64 bits from CPU to memory and memory to CPU. In that case, remember this bus system's amount of lines are related to the word size. And again, the memory has an address. Remember, modern computer memory address can have 64 bits. Previous computer can store 32 bits in the memory location. Just keep in mind that. And the CPU speed is measured by unit we call as a hertz. Hertz means how many instructions can be executed uh, in each cycle. So then that is the unit we are using. How many instructions can be executed per unit time is called as a hertz. Then 1000 hertz are 1 kilohertz, 1000 kilohertz are 1 megahertz, 1000 megahertz are 1 gigahertz. Currently, computer speeds are in gigahertz speed. So this is a machine cycle: fetch, decode, execute, store if necessary, and go back to it again and run in a cycle. Just keep in mind that. So this is the instructions as I told you. That will be if it is a execution of the program, we have to load the instructions from the given memory location, and that address will be keep in the accumulator, and they load the instruction B and does the calculation and store the results. Like, remember, these are the things you should know regarding the machine cycle. So that's what I want to just give you idea about this machine cycle. Just keep in mind. So today evening I will discuss about past paper question related to this one. So thank you for joining, and again I will take the database seminar on this Saturday from 10:30 to 5. Please come. I will discuss all the parts, that is ER diagram, normalization, and schema generation and SQL. All components related to the database management systems will be discussed on Saturday. Please join to that. Thank you.